Welcome back everyone to a new video on the channel. The plan for today's video is to show off the forward voltage sense mod that I have, well, been able to do on reference GTX 580 and also by extension GTX 480 e-power boards. I'm using a 580 here, it's because what I had lying around. Currently, the forward voltage sense lines, as you can see right here, are not attached, and instead it takes the voltage at the VRM output. So if I turn the system on and start a load on the GPU, we should still see a voltage drop. So, I mean, right, so the multimeter is hooked up right here, and these wires, they just go right behind the core. The second set of wires that you saw there, those are for remote sense right here. This right here, in case you're wondering, this is just a 3.3 volt supply. Usually I put an LDO on there, and actually I think, yeah, there's a little PCB on there that I put on there for an LDO. But I think, yeah, the LDO is actually gone, because the one that I had put on there, or I should say the only ones that I have really, can't really handle the current that one of these e-powers would draw on the 3.3 volt rail. So this is just taken straight from the PCIe slot there. Without further ado, I'm going to turn on the Peltier chiller that I've got hooked up right here. So it's going to be a bit noisy, but it shouldn't be too bad. That should turn on. Let me quickly check if the pumps are running. So yeah, that thing's running now, and I should just be able to turn this on. Yep, indeed. Right, you can see, well, it's power cycling. So, there you go. Right, so, booted into an operating system right here. I'm just going to run Heaven. So, idle voltage 1.06. And I guess I will just start... Well, actually, you can check out the temperatures right there as well. So, the Peltier chiller is in fact running, as you can tell. Is it gonna? Are you gonna, like, launch? Thank you. Right. I'll hold the multimeter up like this, so you can see the voltage drop at the same time that I do. If I remember correctly, it's something like 30 millivolts. Yeah, so you can see it goes from 1.06 to 1.03. And depending on the load, it actually goes lower, as you can see. So the higher the load, the more voltage it's going to drop. We've established a voltage drop. So I can actually cancel that again. Yeah, that's the voltage drop across this connection when measuring the Vout voltage directly at the output. What I'll do now is I'll, for one, turn off the Peltier chiller as well as turn off this system. What I'll do now is I'll hook up this, and yeah, we should see a lot less voltage drop. Alright, the GPU is back up and running. As you can see, the sense lines are now attached. I just did that real quick. And already, as you can see, the voltage is actually higher. So previously, without the sense lines attached, it was idling at 1.06 volts, and now it's idling at 1.064. That's just a little difference. However, what's important is the big difference. Well, big. It only dropped like 30 millivolts under load, without the like forward voltage sense lines attached. So like, yeah, arguable how much this does on this. Actually, I didn't even talk about what GPU this is. It's a 6850. So yeah, it doesn't really matter much on this 6850 because, well, it doesn't really draw that much power. But so 30 millivolts on this would actually be perfectly fine. But yeah, this is a 6850 that I just had lying around that unfortunately did not qualify for cheap as chips. And that's because it has Hynix memory on it. But yeah, so much for this. This is just, honestly, it's just a test vehicle to see, like, or to, I should rather say, to show off remote voltage sensing running on one of these e-power boards right here. So I honestly would have really liked to put this on something that draws a little more current, but I didn't have anything. I do have a couple of 780s, but those aren't broken because they've got dead memory. So if I e-powered them, it would just kind of be completely and utterly unnecessary, because that's not the problem that they have. But anyways, I digress. Do the same thing that I did last time. And as you can see, it does still drop a little bit of voltage. But yeah, it's not 30 millivolts anymore. It's like, what, 7, 8 millivolts. So yeah, forward voltage sense on reference GTX 480 and 580 e-power boards. How exactly this mod is done is, yeah, I guess what I'll get into right now. Alright, I'm having to re-record this part of the video because when I did the first take I kind of glossed over an important thing that is necessary when doing this forward voltage sense mod on reference GTX 480 and 580 e-power boards. But I'll get to that later. First thing that you have to do, if you want to do this yourself right here, is to remove these two resistors that are currently in the center of the frame. If I'm remembering correctly, from this perspective, the one up top is the one for Vout, and the one below that is the one for ground reference. I might have mixed that up, so definitely go ahead and double check that. But these two resistors, basically they establish the connection from the sense lines that go to the output of the VRM to the sense lines that go to the controller. Unfortunately, you really can't cut the traces, the sense lines, which would make this more convenient to do, because then you wouldn't need like another set of 100 ohm resistors, which that's actually the part that I forgot to talk about in the first take. But the traces are internal, like they go straight into the PCB, so unfortunately there's really no cutting of these traces and then just soldering to those traces. So yeah, you're gonna have to get some 100 ohm resistors. You can technically actually use, well, not just technically, you can definitely just use the 100 ohm resistors that you're looking at right now. It's just that these are really tiny and by extension really fragile, so I would just not suggest that you do that. The 100 ohm resistors that I used are just good old through-hole foil resistors, if I'm not mistaken. Now you might be wondering why it is that my sense lines right here actually attach to the through holes in the PCB for the fan header, and that's because soldering to these tiny pads over here would just not make for a durable connection, and if you were to ever accidentally pull on these wires, you would just straight up destroy the pads and traces down here. So what I did is, well, the sense lines, they go straight into the PCB, right? So there's vias, and I scratched off the solder mask on these vias on the front of the board and ran wires from those vias down to this fan header right here. And if you take a closer look, you can see that the traces for these two through holes in the PCB for the fan header are gone. I removed them, and by extension fully isolated these two through holes right here from the rest of the GPU. So yeah, there's nothing going to these anymore with these traces gone. You can just remove those traces. You're not going to use the fan header for anything anyways, because, well, it's an e-power board, right? So like it's just unused. So I decided that I was going to use it for this, to make the sense lines, or specifically the attachment points for those sense lines, a lot more durable, because, well, if I pull on these wires now, I might damage the through holes in the PCB, but I'm not going to rip pads and traces over here. Showing which vias exactly it is kind of difficult here because of the Kapton tape. I'll pull it off, and I'll most likely just put a picture up in the video so that you can see which vias exactly it is that you'd have to scratch. But theoretically, if you don't care about the whole durability thing, you can just use the pads that you have over here. So this right here is actually, well, it significantly increases the durability of this connection, but it actually like negatively impacts the accuracy of the voltage feedback, because any additional length of wire that you add to these sense lines is basically, well, it's an antenna just sitting there ready to pick up interference, right? So I just did this for durability, and you definitely don't have to do it the way that I did it. But yeah, that's basically how you do it. And then it's really just you run these wires, right? After the resistors, you run the wires to the back of the GPU. Attach it to a resistor that's on the core voltage rail. That's important, obviously. And yeah, then you have remote voltage sense on reference GTX 480 and GTX 580 e-power boards. And that's actually really all that there's to it. So yeah, hope you guys enjoyed this video. If you did, consider leaving a like on the video, as well as subscribing to the channel if you haven't done so already. And yeah, hope to see you guys again in the very next video. Have a good one.